Welcome to the deep dive. Today, we're really digging into something that's just completely changed the game online. Large language models, or LLMs,
Right.
things like GPT, Llama, BERT. They're not just tech jargon anymore, are they? They're behind so much writing text that sounds, well, human, generating code, even helping fix tricky bugs. They've fundamentally shifted how we find and use information.
Absolutely. And, while they are incredibly fluent, sometimes impressively accurate, it's really crucial to remember they have significant limitations, real risks, too, that aren't always obvious up front.
Hmm.
I mean, think about this. OpenAI themselves did a study, found that even their powerful GPT-3 model gave incorrect or just nonsensical answers about 15% of the time.
Wow, 15%. That's
That
quite a lot.
There really is. I mean, roughly 1 in 7 answers could be wrong or just plain weird. That's not trivial. It tells you you absolutely cannot just blindly trust these things, especially for important stuff. Fluent doesn't mean factual.
Okay, so yeah, that 15% figure is definitely eye-opening. So our mission today for this deep dive is to really get past the hype. We want to pull out the key things you need to know about the real challenges and the limits of these LLMs. What are the critical issues we should all be aware of to use them smartly and, importantly, safely?
Well, probably the biggest one, and maybe the trickiest, is something called hallucination.
Hallucination sounds dramatic.
It kind of is. It's when the model generates information that sounds perfectly plausible, totally confident, but it's actually factually wrong, or maybe just completely unrelated to the context.
Ah, okay.
And it's not a small glitch. It really hits at the core of whether you can trust what the AI tells you. It often comes down to, well, biases baked into the data, or the fact that it doesn't really understand the world, or just gaps in what it was trained on.
And I guess these aren't just tiny mistakes either.
Not at all. You could have an LLM confidently say, the Great Emu War of 1932 was a conflict between Australia and New Zealand, which is just completely made up. Or maybe it tells you Da Vinci painted the Mona Lisa in, I don't know, 1815 instead of the early 1500s. They sound convincing, but they're just flat out wrong.
Yeah. Okay, I see how that could be a problem.
And the implications, they're pretty serious. It can completely destroy trust in the technology, obviously. There are ethical issues, too, spreading misinformation, for example.
Hmm.
And think about using this in critical fields like finance or medicine or law. Bad information there could have huge consequences. Plus, there's potential legal trouble, for both the developers and the people using the AI's outputs.
That does paint a concerning picture. If getting it wrong can damage trust and even lead to legal issues, what are people actually doing to try and fix this? How do you control these hallucinations?
Well, there are a few main strategies. First, really focusing on the quality and, importantly, the diversity of the training data.
Mm-hmm.
So, for instance, a medical LLM shouldn't be trained on, like, random websites. It needs verified medical texts.
Makes sense.
Second, using really robust ways to check the output. That often means having actual human experts review what the AI produces, especially in high-stakes areas like law. We're also seeing more human-in-the-loop systems.
Human in the loop.
Yeah, like having a human agent quickly review an AI-generated customer service response before it goes out.
Got it.
And finally, there's a big push towards explainable AI, XAI.
XAI, explainable AI.
Exactly. Think of it as trying to understand how the LLM reached its conclusion. Why did it give that answer? That's vital if you're relying on it for, say, financial predictions or medical advice. You need to know the why. Another really big hurdle for LLMs is, well, their knowledge gets stuck in time.
Stuck in time.
Yeah, they're kind of like super smart graduates who just stop learning the day they leave university. Once trained, their knowledge is basically frozen at that point, so it gets outdated.
Oh, okay.
And retraining them from scratch is incredibly expensive and takes massive resources. Training GPT-3, for example, took something like 355 GPU years and cost millions.
Wow. So if an LLM was trained only up to, let's say, 2020.
Exactly. It would know nothing about major developments in the COVID pandemic after that point. It'd be operating in a kind of time warp.
Okay, so that cost of retraining sounds like a huge bottleneck. Are there clever ways around that? How do you keep them up to date without rebuilding them constantly?
Yeah, people are working on it. One approach is just scheduling regular retraining, like planned updates.
Right.
Then there are techniques called incremental learning. This allows models to sort of absorb new info without needing a full, costly retraining. Think about a news summary. AI needs to stay current daily, right?
Yeah, that makes sense.
We're also seeing hybrid models. These combine the LLM with systems that can pull in real-time data. So an LLM helping with product questions could check a live database for current stock levels, for example.
Ah, clever.
And really importantly, using feedback from users to flag when information seems old or wrong, that can trigger updates. They also tend to struggle with really complex reasoning.
What do you mean by complex reasoning?
Tasks that need multiple logical steps or understanding really subtle nuances. They often just give nonsensical answers, like ask it a multi-step math problem that requires carrying over numbers. It often messes that up.
Hmm.
It really shows that even these advanced models, these transformer models, they don't actually think or reason like a human does.
And that must have real-world consequences too, like in customer service.
Definitely.
Yeah.
An LLM might handle basic questions perfectly, but if a customer has a really complicated issue with lots of factors,
Hmm.
it could just fail completely,
Hmm.
leading to, very unhappy customers.
So how do you tackle that problem, making them better reasoners?
One way is using hybrid AI systems. You pair the LLM, which is great with language, with something like symbolic AI, which is better at logic and rules.
Hmm.
IBM's Watson is kind of a famous example of blending these approaches.
Okay.
Again, having humans in the loop is key. Human moderators can step in and refine answers for tricky or sensitive situations like OpenAI does with ChatGPT.
Right.
And of course, feeding them better training data that specifically includes complex reasoning examples. That's a big focus for places like Google's DeepMind. And again, using explainable AI to try and understand how they're attempting to reason. Programs like DARPA's XAI are looking into this. And another thing they often trip up on, just the sheer messiness of human language.
Messiness. How so?
Well, think about idioms like spill the beans, or slang, figurative language, sarcasm, irony. LLMs can really struggle to get the intended meaning. They might take things too literally or just completely misread the context.
Yeah, sarcasm would be tough for a machine. So how do we help them speak human better? Get all those subtle cues.
A big part is improving the training data, again, making sure it includes a massive range of these linguistic quirks. OpenAI's GPT-3, for instance, was trained on just enormous amounts of text to try and capture idioms and nuances.
Okay.
Developing more sophisticated algorithms helps too. Google's BERT model, for example, uses something called masked language modeling. It basically learns context by having to predict missing words in sentences. Human feedback systems, like with IBM Watson Assistant, are crucial for refining how they handle these subtleties. And building models that are more context-aware, meaning they remember what was said earlier in the conversation, like Amazon Alexa tries to do, that helps them handle language much more naturally. So we've talked about the AI's brain quality and what it learns, but there's also a sort of fundamental limit, almost like it's working memory.
A memory limit.
Yeah, it comes down to computational constraints, beyond just the training cost. LLMs can only process a certain number of tokens at once.
Tokens.
Think of tokens as like pieces of words or characters, the basic units of language for the AI. GPT-3, for instance, has a limit around 40 to 96 tokens. If you try to feed it more than that, it might just error out or chop off the end of your input.
Okay, so if I'm, say, a lawyer trying to get an AI to analyze a long 50-page legal document, I can't just paste the whole thing in. How do I deal with that token limit?
Exactly, you can't. So one technique is token optimization. You learn to phrase your requests really efficiently, cutting out extra words, almost like writing a tweet to fit a character limit.
Right, being concise.
Another common method is chunking. You break that long document into smaller pieces, maybe a few pages each, process each chunk separately, and then maybe feed the summaries of those chunks back in for a final overview.
Ah, okay, like reading chapter by chapter.
Precisely. And sometimes, for simpler tasks, just using a smaller, more specialized AI model is more efficient and avoids hitting those token limits altogether. Now, switching gears a bit, let's talk privacy. This is a big one.
Yeah.
LLMs are incredibly good at spotting patterns.
Yeah.
Right. Well, that means they can sometimes infer sensitive stuff from the data you give them, even if you didn't explicitly state it. This can lead to, accidental data leaks and serious privacy breaches.
Okay, that sounds worrying. So, given that they're processing everything we type in, what are the absolute red lines? What should you never share with an LLM like ChatGPT?
That is probably the most critical question for anyone using these tools. The simplest rule: treat it like a public forum. Never input anything you wouldn't be comfortable shouting in a crowded room.
Okay, that's a good rule of thumb. So what does that include specifically?
Definitely personal identifiable information, PII, full name, birth date, social security number, home address, phone, email. The risk is identity theft, fraud. It's serious.
Right.
And remember, that incident, over 100,000 ChatGPT account details were found on the dark web between mid-2022 and mid-2023. Also, things like financial info, credit cards, bank logins, obvious risks there.
Obvious.
Passwords and login credentials, never share those. That's giving away the keys to your digital life. Use strong, unique passwords and two-factor authentication everywhere.
Good advice.
Private or confidential information, personal secrets, sensitive work stuff. AI doesn't get human context, so the risk of accidental disclosure is high. It could damage your reputation or your company's competitive edge. And finally, proprietary info or intellectual property. Things like patented ideas, copyrighted material, trade secrets. Sharing that risks theft, lawsuits, losing your commercial advantage, and biometric data, like your face scan. Especially dangerous because you can't just change your face if it gets compromised.
Wow. Okay. That's a pretty comprehensive list. Yet I've heard some people actually do share very personal things, maybe for tailored advice, almost like therapy or analyzing dreams, and they find real value in it. How do we square that with these privacy risks?
It's a really tricky balance, isn't it? People weigh the perceived benefits against the risks. But the fundamental advice remains, treat it like it could become public. Once data is uploaded, you effectively lose control. It could, as they say, live forever somewhere.
Right. So what's being done technically to help mitigate these risks?
There are some clever techniques. Differential privacy adds statistical noise to data, so you can analyze trends in large data sets without identifying individuals. Google Maps uses something like this. Then there's federated learning. The AI model trains on your device, using your data. But crucially, the raw data never leaves your device. Only the learning updates are sent back centrally. Apple and Google's Gboard use this.
That sounds safer.
And things like data anonymization, stripping out identifiers, and secure multi-party computation, which lets different parties compute on combined data without ever seeing each other's raw data. Microsoft Azure is exploring this. Moving on slightly, let's talk about the training data itself again. The LLM's performance is just massively dependent on the quality, the diversity, the sheer scope of that data.
It's that old saying, garbage in, garbage out, right?
Exactly. If the training data is limited or biased or just plain inaccurate, the AI's output is going to reflect that. It's unavoidable.
So this huge amount of data that feeds these AIs, where does it all come from? And who actually owns it?
Well, data comes in two main types. Structured, like neat tables of sales figures, and unstructured, think text, audio, video, images. Sources vary. Companies use their own internal data, like Spotify, using your listening history for its AI DJ.
Right.
Or they get it externally. Sometimes from data vendors. Reddit, for example, sells access to its content for AI training. There are open data sets available too. And then there's the controversial practice of scraping the internet, just grabbing publicly accessible data.
Controversial why? Copyright.
Precisely. Scraping carries a really high risk of copyright infringement. Data itself isn't strictly owned in a simple sense, but lots of rights attached to it. Copyright, database rights, confidentiality agreements. That's why you see major lawsuits like Getty Images suing Stability AI because, they allege, Stability used Getty's copyrighted images in its AI training without permission. And even if a company does get a license for data, they need to be really sure the person selling the license actually holds the rights to it. It's complex.
Okay, now let's broaden out a bit to the societal and ethical side of things. A huge concern is bias.
Bias, right, because the training data isn't neutral. Exactly. Yeah. LLMs can accidentally learn and then repeat the biases and stereotypes that are already present in the data they were trained on. This can lead to outputs that are unfair or discriminatory.
And we've seen examples of this, haven't we? Like an AI trained mostly on texts by men, assuming certain jobs are always done by men.
Yes, that's a classic example.
Yeah.
Or things like facial recognition in online exam proctoring software, having higher error rates for people with darker skin tones, unfairly flagging them. It's subtle, but deeply problematic.
So how do you fight that bias if it's baked into the data?
It's tough, but there are strategies. One is making a conscious effort to use training data that is diverse and representative, pulling from different cultures, backgrounds, perspectives.
Okay.
You can also apply technical methods like data augmentation or specific debiasing algorithms to try and counteract imbalances in the data. And ongoing testing is crucial, using tools designed specifically to detect and measure bias in the AI's outputs. And it's really important to stress, LLMs don't understand human emotions or complex relationships. They just can't. So they can't truly replace human connection or creativity or nuanced judgment. They're powerful tools, yes, designed to augment what humans can do, not replace us entirely.
That raises a key point. it's not just about the technology, is it? It's about how we choose to use it, how we guide it. What are the big ethical discussions happening right now to try and put some guardrails around AI?
Well, lots of groups are working on ethical guidelines, governments, big tech companies like Google, IBM, Microsoft, nonprofits like OpenAI.
Okay.
And there seems to be broad agreement on about 5 core principles. Things like transparency, fairness or justice, responsibility and accountability, privacy, and non-maleficence, basically, do no harm.
Seems reasonable.
But the devil's in the details, how those
Yeah.
principles get interpreted, who they apply to, and how they're actually implemented. That's where you see big differences between different organizations and cultures. And even with those principles, there are some pretty significant gaps in the current conversations.
Gaps, like what's being missed?
Well, for one, sustainability. AI uses enormous amounts of energy and water, but that environmental cost often gets overlooked in ethical discussions.
Interesting.
Another is solidarity. Questions like, how do we make sure the benefits of AI are shared fairly? Should people be compensated if their data is used to train these powerful, profitable models?
Just questions.
Integrity is another, being truly transparent about best practices and also about when things go wrong. And the lack of diversity within the AI field itself is a problem because it shapes what gets prioritized and what risks get noticed.
Yeah.
Plus, some really critical issues like the potential for AI to be abused politically. Think election interference, deepfakes, propaganda often don't get enough attention in these framework discussions.
Yeah.
It's also striking that right now, the global conversation about AI ethics is heavily dominated by voices from the global north and predominantly by men.
Right, which means
Crucial perspectives, risks, and ethical considerations that might be more apparent to women or to people in other parts of the world might be getting missed. There's also a worry that just having principles isn't enough. Unlike, say, medicine, there aren't really established ways to hold AI developers or users accountable when ethical lines are crossed.
you mentioned sustainability and the environmental cost just now. That's something I've heard whispers about, but it doesn't seem to get much coverage. Is it really significant? What are we talking about in terms of energy and water?
Oh, it's significant. The numbers are actually pretty shocking when you dig into them.
Okay, give us the numbers.
Right. So the International Energy Agency put out a report in 2024. They projected that by 2026, the combined energy use of data centers, AI, and cryptocurrency could equal the entire energy consumption of Japan,
Wow. The whole country.
the whole country. And generative AI specifically is expected to use 10 times more energy in 2026 than it did just back in 2023.
10 times.
Yeah. And get this, training. Just one large model, like ChatGPT, can consume as much electricity as about 120 American homes use in an entire year.
That's staggering. Why so much energy?
Well, the machine learning process itself, especially the training phase, is incredibly computationally intensive. And the massive data centers that run these models, they need constant power, often from fossil fuels like gas or coal. Plus, every time a model needs retraining, that's another huge energy investment. And it's not just electricity, it's water too. Massive amounts of fresh water are needed to cool the servers in these data centers.
Water. I hadn't even thought about that.
Yeah, Google, for instance, reported using around 5 billion gallons of water for its data centers in 2022 alone. That was a 20% jump from the year before.
5 billion gallons.
Billion with a B. And some projections suggest that by 2027, the total water footprint of AI globally could reach 1.7 trillion gallons a year. That's more than half of what the entire United Kingdom uses annually. It's just not sustainable at that scale.
Okay, those numbers are genuinely shocking. So what does this all mean for, the average person, someone who maybe just uses AI through a Google search or gets help writing an email? Am I personally contributing significantly to this huge environmental footprint?
Well, look, just telling people don't use AI isn't realistic, is it? It's becoming embedded in so many things we do online.
True.
But there are things we can push for. One is much greater transparency from the tech companies about their actual energy and water consumption. Right now, they're often not required to report it in detail.
Right. Demand transparency.
We can also educate ourselves and others about the impact. Knowing that, say, generating a short 100-word email with AI might use more water than is in a small plastic bottle, that awareness might encourage what some call digital sobriety, just being a bit more mindful about our usage.
Digital sobriety. I like that.
And on the technical side, there's ongoing work to develop more energy-efficient AI models and training methods. Plus, strategically locating new data centers in places with abundant renewable energy sources is crucial.
So we've covered a lot of ground today. It's clear LLMs are incredibly powerful, truly transformative tools. But they come with this whole suite of serious challenges, don't they? From making things up, these hallucinations, and having outdated knowledge, to posing real privacy risks, raising complex IP issues, reflecting societal biases, and, as we just heard, having a pretty hefty environmental impact.
Yeah, absolutely. And if you sort of zoom out, connect it all to the bigger picture,
Mm-hmm.
what this deep dive really highlights is that LLMs aren't, replacements for human thinking or human judgment.
Hmm.
They're more like incredibly powerful, but definitely flawed assistants. Tools that demand we engage with them critically, thoughtfully. What's really fascinating now is seeing how not just the tech evolves, but how our understanding of its deep connections with society, ethics, and even the planet is also evolving.
So the takeaway for you listening is hopefully to approach AI with this informed perspective. Keep the excitement, sure, but balance it with a healthy dose of caution and critical thinking.
Exactly. And maybe a final thought to leave you with. Given everything we've discussed, the huge potential and the undeniable challenges, how will you choose to interact with these powerful systems? What responsibility do you feel you have, not just as someone using AI, but as someone participating in shaping a future where AI and human ingenuity can hopefully coexist, thrive, and do so sustainably?